Hello everyone, my name is Zhiyi Zhang Beryl. My ZID is z5452546, and this is my ID card. I'm delighted to talk about an interesting topic, understanding the solar system. First, let's talk about the Kepler's laws. The Kepler's laws define the laws of motion of the planets around the Sun. The first law states that the orbits of the planet around the Sun are elliptical and that the Sun lies at one of the foci of the ellipse. The second law states that the lines connecting the planets to the Sun sweep over equal areas in equal times. The third law states that the square of an planet's period of revolution is proportional to the cube of the half-length axis of its orbit. So let's move on to the questions. For question 9a, the answer is yes. This is due to the fact that the planets and the moons pull on each other and thus orbit around their common center of mass. The gravitational dynamics we talk about in class are relevant not only to the solar system but also to the planet-moon system. Thus, the motion of the planet is closely related to the motion of the moon. For question 9b, here are the pictures provided for previous questions. Each of the planets and moons move around their common center of mass, but the Sun dominates. So the center of mass is very closely to the Sun and is only slightly displaced by the mass of the Sun or the mass of the planet. Even if the mass of the planet were to double or the mass of the Sun or to increase dramatically, by a factor of 1.5, the center of mass would only be slightly adjusted. However, more solar mass would shorten the distance between the Sun and the planets and shorten the period, but the center of mass would still be near the Sun. For question 9c, the center of mass in a planet-moon system significantly differs from that in a star-planet system. In a star-planet system, the star's significantly greater mass keeps the center of mass very close to or even within the star, making the star's motion less perceptible. Additionally, the dynamics in a planet-moon system are more balanced, where in a star-planet system, the planet's motion is more strongly dominated by the star's gravity. For 14a, let's look at the graphs I have been trying to make it a circle. It presents a clear trend. As the semi-major axis increases, the square of the period over a cube of the semi-major axis decreases. By Kepler's third law, which states that the square of the operational period of a planet is proportional to the cube of its semi-major axis, the trend is an auto-match. This data is thus consistent with Kepler's third law, and we can show how it applies to planets in orbit around our solar system. For question 15a, the answer is Mercury, which is the nearest one from the Sun. B, alternatively, the one farthest from the Sun, Neptune, would have the lowest operational velocity. So what is the reason for this? These differences in orbital velocities are the result of gravitational and orbital mechanics. Orbital speed is also determined by the gravity, which is inversely proportional to the square of the distance from the Sun. Thus, planets closer to the Sun feel a stronger gravitational pull and must move faster to maintain their orbits, while planets on the periphery receive less gravitational pull and move more slowly. Finally, what I learned that the mass of the Sun is the primary contribution to where the center of mass of planetary system lies. As mass varies, the center of mass remains close to the Sun. Confirming Kepler's laws also helped me realize how affected orbital size, period, and velocity are by mass and distance. However, what really makes these observations fascinating is the richness of dynamic mechanisms involved with gravitational influences. Thank you for your listening.